Alright guys, so pretty much what we've been doing lately is looking at complex numbers and polar numbers and how that applies to vectors and Argand diagrams and all that kind of stuff. And you know what? We're going to do just a little bit more of that today. We're going to look a little bit deeper into what we have and hopefully get the final step in what we need to prove really what the point of all this is, which is De Moivre's theorem. And so that's what we're going to do today. The first thing that we want to talk about is just looking at two vectors being multiplied by each other, z1 times z2. Alright, now if we define each of these and we say that z1 equals r1 cis theta 1, and we say that z2 equals r2 cis theta 2, then essentially what we have is z1 times z2 is equal to r1 cis theta 1 and r2 cis theta 2. Right? Now, obviously we can multiply those. We end up getting r1, r2. Now remember, r is just the magnitude of z, and the theta is the argument there. So we've got r1, r2, cis theta 1, cis theta 2. And you may say, well, that's boring. I could have done that. Well, what I want to show you is what happens if we open up the cis. Okay? So let's go ahead and we're going to rewrite that. So we've got r1, r2, but we're going to rewrite the cis as cosine of theta 1 plus, there's the I sine of theta 1. And then the same thing with the cis 2, so cosine of theta 2 plus I sine of theta 2. And we're going to go ahead and do the expansion here. So the r1, r2, of course, will stay the same. We've got cosine of theta 1 times cosine of theta 2, which will give me cosine theta 1, cosine theta 2. We've got cosine theta 1 times I sine theta 2. So we're going to have a plus I cosine theta 1 sine theta 2. Then we'll have the I sine theta 1 times cosine theta 2, so plus I sine theta 1 cosine theta 2. Just wait, it's going to be worth it, I promise. And then we'll have I times I, so minus sine theta 1 sine theta 2. And if we rearrange this, we put the real parts together and the imaginary parts together, then what we end up with is r1, r2 times cosine theta 1, cosine theta 2, minus sine theta 1, sine theta 2. That should start to look familiar a little bit. And then plus I times cosine theta 1, sine theta 2, and plus sine theta 1, cosine theta 2, and that should also look a little bit familiar because we've seen both of those things before. Cosine theta 1, cosine theta 2 minus sine theta 1, sine theta 2, you may remember as being cosine of theta 1 plus theta 2. If you don't remember that, look in your equation booklet. And then we've got cosine theta 1 sine theta 2 plus sine 1 cosine theta 2, which is essentially sine of theta 1 plus theta 2. So again, we have just this, the formula from your equation packet. And if we now rewrite this, we have r1, r2, cosine of theta 1 plus theta 2, plus I, and some of you may see what I'm trying to get at right now already, sine theta 1 plus theta 2. And one more parenthesis. Yeah, nope, that's it. Okay, and you'll notice that we then have cosine of theta 1 plus theta 2 plus I sine of theta 1 theta 2. And what does that mean? Well, that means, my friends, that z1 z2 is equal to r1 r2 cis theta 1 plus theta 2. Now, if that isn't cool, I don't know what is. Actually, I know a lot of things that are cool in math. But anyway, let me just show you kind of what this would look like if we had put it on an Argand diagram. What does this really mean? Okay, so if we were looking at an Argand diagram, Okay, for let's just consider right now that R1 equals 1 and R2 equals 1. Okay, so we're thinking of a unit circle here. Okay, which I know that's a beautiful circle. So let's say we've got Z1 right here and Z2 right here. Okay, both of them have a length of 1. So here's angle 1 for Z1, and Z2 is then angle 2. Sorry, goes all the way down. So you have angle 1, you have angle 2. So if I were to multiply Z1 times Z2 on the unit circle, then the result would still have a length of 1, R1 times R2. So I'd have a result that still has the length of 1, and then it would be cis, and the angle would just be theta 1 plus theta 2. So I would add those two together, and whatever that is would end up giving me something here, which this angle is now the sum of those two. Alright, so just kind of an interesting concept, an interesting idea, but that's what's going on here. Okay, so just in summary, we noted that if we multiply Z1 and Z2, then what we end up with is the two magnitudes times cis theta 1, theta 2. Another thing to take note of is that if we just look at what we have, then the first thing that we get is that the length of Z1 times Z2 is just the length of Z1 times the length of Z2, which I think you've seen that before. All right, but that's just the first part of it, right? Z1, Z2, the length is our R1, R2. Okay, the second thing that we want to get is that the argument of Z1, Z2, right? So the angle of Z1, Z2, when we multiply those two, the resultant angle is then the argument of Z1 plus the argument of Z2, right? The result is then the angle of argument of 1 plus the argument of 2. Alright, so these are a couple of formulas that you may or may not find helpful later, but this one right here you definitely will. Okay, so I think what I'm going to do is I'm going to go ahead and just show you one more thing, just kind of for your information, and then I'll create one more video that just kind of works through a couple of examples in case you need it. Alright, so the second thing I want to look at is with respect to this, okay, what if it wasn't Z1 times Z2? What if it was Z1 divided by Z2? Alright, now this shouldn't be too bad. We understand already that the reciprocal of Z is 1 over Z, and you can probably see where I'm getting at already. Instead of doing Z1 divided by Z2, we're going to do Z1 times the reciprocal. Okay, so 1 over Z2. So if we can multiply instead of dividing, we've already got a formula for multiplying, right? So let's see if we can come up with that. All right, so what we're going to do is we're going to define Z1 as being R cis theta, and we're going to find Z2, actually we're going to define the reciprocal of Z2 as being rho cis theta. Sorry, this is not Z1, Z2, I'm lying. This is just Z and 1 over Z. Because we know that if we multiply Z times the reciprocal of Z, then we get 1. And so we're going to define each of these. We're going to hope that we can set up a reciprocal of Z using just another R and theta essentially. So what we're going to do now is we're just going to say, okay, that means that R cis theta times rho cis alpha equals 1. And so from there we can and we need the we need the argument part, so we need the cis 0 because there's no angle for this one, right? There's no angle associated, there's no imaginary part, and so it's just cis 0. And so from this point we know already that when we multiply 2, it just ends up being what we had up here. So we have R rho cis theta plus alpha, which equals 1 cis 0. Okay, now because of this, we already can look at our row. So our row needs to give us the modulus part of this, right? The part that's not inside of the sys. So therefore, rho has to equal 1 over r. Now if we look at the theta and alpha, those have to add together to give me 0, so that these multiply together to give me 1. Okay, so if the sys 0, then what that means is that theta plus alpha has to be 0, and therefore alpha must be negative theta. And so because of this, we can say, well, if z equals our cis theta, that means that the reciprocal of z, 1 over z, equals 1 over r cis negative theta. And that's going to be a really easy way for us then to do division. Okay, so essentially we can create our final step here, which is, okay, well, how do I do z1 divided by z2? Well, we don't. We do z1 times the reciprocal of z2, which means we do essentially this. We'll say, okay, well, z1, so I'm going to have the r1, so z1 is r1, and then it's going to be multiplied by r2, but r2 is going to be the reciprocal, so it's going to be 1 over r2, and then we'll have the cis, and then we'll add the angle for z1, so theta 1, and we're going to add the negative for the reciprocal of z2, so in essence minus theta 2. And so this formula right here, which you'll usually see as r1 over r2, cis theta 1 minus theta 2, will not be given to you on any formula packet, but you'll find that helpful as you are dividing vectors, especially with complex stuff. Okay, so that's the basic idea behind everything that we're going to be doing. I'm going to do one more video that just works through a couple of examples so you can see how this is used. Again, the main point of this really isn't what we're doing now, it's what we're going to do next class with the Demoivre's theorem. All right, so have a look at the next video, see some examples, we'll work some questions in class, and we'll probably get right into Demoivre right at the end of class next time. Cheers.